Good morning, everyone. I'm Mattia Cielo from the University of Naples, and today I'd like to talk about some topics covered during the first EuCAPT school on cosmology in Valencia. The first thing I'd like to talk to you about is the CMB, the cosmic microwave background. It represents one of the main cornerstone in the history of science, and it it can be thought about a snapshot from the very early universe. It represents the photons, so particles of light that were emitted when the universe was a hot and dense plasma. So these photons have been traveling through the space and time for billions of years. And when we observe the CMB, it is basically uh, like looking at a picture of how the universe was in its very early stage. So what we observe today is essentially an homogeneous and isotropic background of this radiation. However, we can observe very tiny fluctuations in the temperature spectrum. These tiny fluctuations are of the order of 10 to the minus 4. So they are very tiny, but they are present. But as I said, this represents one of the main one of the main observational achievement in the science history. But why? The reason why it is so important, this observation, is that it helped the scientists to make other questions, like why we observe this homogeneous background. Unfortunately, this kind of observation is in contrast to our cosmological model. So, in order to explain better this observation, we need to go deeper in the history of the universe and imagine some mechanism that could produce such background. So, if we look at the history of the universe, we can see here the cosmic microwave background. But before the CMB, before the CMB was formed, there were many other stages of the universe. And if we look on the left of this picture, we will arrive at a period which is called inflation, that is actually the stage of the universe during which the initial conditions for our universe were formed. Inflation is a very successful mechanism which basically describe how quantum vacuum fluctuations are stretched and then form what are the initial conditions for our universe. So the goal one the goal of next generation of scientists is to explore all the relics and all the forecasts that came from the inflationary theory, and in particular the dynamics of such quantum fluctuations during the very early stage of our universe. From this perspective, quantum fluctuations are the seeds of the universe we observe today. But those quantum perturbations can be divided into actually three kinds. First, the scalar perturbations, then the vector ones, which are less important from the theory point of view, and then the tensor ones. The, the scalar ones are responsible for the density fluctuations, and then they are responsible for the fluctuations in the temperature. But not also. It's very interesting to study the dynamics of density perturbations also with respect to some new very hot topic that are, for example, the production of primordial black holes as a candidate for dark matter. But beside the production of scalar perturbations and the stretching of scalar perturbations, other kind of perturbation cover great importance in toward these studies. There are the gravitational waves, the tensor one. The gravitational waves are also are very often called the smoking gun of inflation because they carry very distinct and clear information about the parameters of the functions that are involved in the inflationary mechanism. So what's next? The next step are the experiment. I'd like to mention just a couple of them, but the future of science is not just limited to these two, but these two are the LISA mission, the Laser Interferometer Space Antenna, and the Einstein Telescope. The LISA mission has as a task specifically the goal to reveal the primordial gravitational wave background, that is the gravitational wave background from inflation, while the Einstein telescope will tell us more about many aspects and many features of our universe. And among them, it can bring information also about the primordial stochastic gravitational wave background. So thank you so much for your attention.